Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today's discussion is basically going to be a discussion on one of the measures of a central tendency. And of course, defined that we have a specific set of course, numbers which we're going to use in representing a specific group of data. And these are going to be single values referred to as averages. Now, in our last discussion, I had mentioned a few of these particular averages, which are going to be representing a group of numbers. And in this case, I mentioned the concept of the mean, the mode, the median, and of course, I had talked about the concept of quantiles. And in this case, I've mentioned for the first and the last one, there are also subsets which we are going to look at under the concept of arithmetic mean, the geometric mean, the harmonic mean, and weighted mean. And of course, in this specific case for the quantiles, we shall look at the quartiles, deciles, and percentiles in that particular order. Now, in this case, we are going to look at a particular set of average that we refer to as arithmetic mean. And that's going to fall under the broader category of this specific average that we refer to as the mean. Now, in this case, basically the arithmetic mean is going to be a sum of the magnitude of items divided by that specific number of the items. And this is going to be given in a particular algebraic form by considering a specific case or a general case that we are given for a specific variable x. And we said that we can represent the variable, the items of the variable x using this specific representation whereby we had x1, x2, perhaps to the last item given as xn. And therefore, we're going to represent the sum of these specific items as the summation from the first item to n items of these particular variables, which we're going to give in terms of a general representation for xi. So in this case, of course, we have said that therefore the arithmetic mean is going to constitute a sum of the magnitude of items divided by the number of items. And in this case, of course, we are going to use this particular notation for n representing the number of items given as such. So therefore, we're going to denote this specific concept of arithmetic mean by using these particular initials. So in some cases, we're going to use this specific initial for m given as such. And in other cases as well, we're going to use an x with a bar implying the concept of the arithmetic mean. So therefore, from that specific statement, we can generate our relationship of the arithmetic mean using this specific relationship, whereby we have said that the arithmetic mean basically is the sum of a particular set of items, or the sum of the magnitude of items divided by the number of items. So we're going to consider our items from the first one to the last one, which has been given as n, of these specific items divided by the number of items. And this is going to give us the general representation of a particular set of this arithmetic mean. And in some cases, we're going to consider a case whereby perhaps a particular set of items are going to appear perhaps 2 times or 3 times. And in this case, this is going to constitute the concept of a frequency. Now, in this case, we're going to also look at a scenario whereby perhaps 2 or more items are going to appear once or twice. And that therefore is going to require us to find a representation for those specific items which are going to occur in a particular frequency. Now, therefore, if we are going to have that particular representation, we can consider the case of course, our general representation whereby we say these are going to be a range of numbers to x and n. And therefore, if we have a particular set of items occurring f1 times, and let f represent our frequency, or the number of times in which this particular item is occurring, and x2 occurring f2 times. This is going to go up to a range of values of xn, which was our last item, occurring fn times given as such. And this is going to create a specific relationship whereby we are going to see that for each respective item, we can consider its particular frequency, and therefore that's going to give us the nature of their specific average, which is basically the arithmetic mean. So therefore, we are going to use this aspect of frequency in our representation of the arithmetic mean by having it given in terms of the summation from the first item. And in this case, we are going to use the concept of classes, whereby these are going to be the total number of course, occurrences for each individual item given as such. And therefore, we're going to use that specific set for classes given as case. So I defined the concept of classes from our introductory video. I'm going to put a link of that particular video in the description box of this so that we can check on that. So we're going to have that one given in terms of the product of frequency and the ith, of course, value for that specific variable of x, and that is going to be divided by n. And in this case, n can as well be substituted for the total number of frequencies given in terms of the summation of all the frequencies given as the summation between 1 and k of fi given as such. So this is going to be a representation of the arithmetic mean using that set of data that is going to occur using a particular frequency. And of course, we're going to use that specific concept in case we come across it. Now, I'm going to use a very simple set of data which is going to assist us, of course, evaluate, of course, an arithmetic mean of a set of numbers or a class of course, items. And that is going to form our last bit of this specific discussion. Now, on my right side of the board, I've given a specific set of items of this variable of x occurring in a number of 2 times, 3 times, 2 times, 1 times, 3 times, and 1 times. And these are for the respective observations of 2, 3, 7, and 8. And therefore, for us to compute the arithmetic mean from this one, we're going to have this one given in terms of this specific product. Remember, we had said that from a particular formula for finding the arithmetic mean for a data having that specific frequency, we had given it in terms of the summation between I is equivalent to 1. And of course, we had said that that is going to go into a number of n times, and then frequency, the product of frequency and the xi observations are given together with the sum of course, given as fi. And in this case, we are going to, of course, take the number of these specific classes given in terms of k. Now, for our frequency distribution, we're going to have this one given in terms of k, having it as such. So in this case, we are going to consider this specific data. And therefore, for us to find this specific arithmetic mean, we're going to find the product between fi and xi. And this is going to constitute this specific product of 2 by 2, 3 by 1, 7 by 3, and then 8 by 1. And that is going to give us, of course, a total of 36. So the summation of this specific set of data from the first one to the last one gives us 36. And therefore, our numerator is going to be given in terms of 36. And of course, as we said, this is going to constitute the n number of observations given as that. The first observation is 2, 3, 7, 8. So 1, 2, 3, 4. Of course, this is going to be basically, we're going to have the total number of observations for this one for their respective frequencies. So this is going to be 2 plus 1 plus 3 plus 1. And this is going to give us a total frequency. The summation of frequency basically given as 7. And therefore, this is going to give us the ratio between 36 and 7. Therefore, our arithmetic mean is going to be 5.15 given as such. So this is one of the ways in which we're going to use in evaluating the arithmetic mean for a frequency distribution. And of course, as we said, from the general case, of course, from our introductory part, we're also going to use for row and group data using this specific representation, whereby we say this is going to be the summation of from I to n of these specific values for x variable divided by n given as such. So I hope we are going to remember this specific representation in case we come across them in our various discussions on the concept of the arithmetic mean. So that is it for now. Kindly subscribe and check our description boxes of various links which we're going to put there on specific topics on the concept of statistics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.